So today we're looking at solving quadratic equations. We're going to show you 4 types of solving quadratics. There are basic factoring equations, there's advanced factoring, there is solving using square roots, and then there is quadratic formula. Okay, so the first type we're looking at is the basic factoring. So with basic factoring, what we're basically doing is find the values that will multiply to give you positive 35 and add to give you negative 12. If you do negative 7 and negative 5, that gives you positive 35, but negative 7 plus negative 5 gives you negative 12. So we're going to put those values right here. Okay, then what we're going to do is we're going to set each one of these factors equal to 0, and then solve them for x. And there you go. For number 2, same idea. We have x and x. The two numbers that multiply to give you 72, but add up to give you 17. So you could do 8 and 9. So 8 times 9 is 72, and 8 plus 9 is 17. So we're going to do plus 9 and plus 8. So then we take each of these factors, set them equal to 0, and solve for x. The next type is advanced factoring. Now I'm going to show you 2 different ways to do this. I'm going to show you one way on number 3 and then a different way on number 4. They would both work for either one, but I want to give you some more options because advanced factoring is technically really one of the harder ones to do. Okay, the first one is called factor by grouping. So what you do with this is multiply the first term and the last term. So you get 3 times 8. 3 times 8 is 24. What we want to do is figure out what the factors of 24 are that will add up to give you 25. Now it's going to give you 24 and 1. So we have 3x squared. What we're going to do is replace the 25x with our 2 new factors. Plus 24x plus x plus 8. Now the reason I call this factor by grouping is that we're going to group the first 2 factors and the second 2 factors together. From here, we're going to take out the greatest common factor of each set of terms. So out of 3x squared and 24x, we can take out a 3 and an x. If we do that, we'll be left with x plus 8. Now out of x and 8, technically you really can't take anything out you can think of, but there is always something to take out, and you can always take out a 1. Okay. So now what you're doing is you take the terms out in front, the 3x and the 1, and they become a factor. Okay, and then you know you're doing this right if the 2 terms that are in the parentheses still are the same. If they are the same, you're on the right track. If they're not the same, you've probably done something wrong. And those become your other factors. Now that we've factored our quadratic, we can set them both equal to 0. And then solve for x. So x will equal negative 1/3 and negative 8. All right. So now it's factor by grouping. I'm going to show you a different method that kind of works the same way, but I think it might be actually a little quicker. So to do this one, you're going to multiply again the first term and the last term. So 4 times negative 35 is going to be negative 140. Okay. And again, you want to find the factors of negative 140 that will add up to be negative 4. So let's try negative 14 and positive 10. So negative 14 times positive 10 is negative 140. Negative 14 plus 10 is going to be negative 4. Now rather than put these numbers back into the equation and then factor it by grouping, we're going to do what's called the bottoms up method. All right. What you do is you take your 2 terms that you just found, your negative 14 and your 10, you're going to use this number in front as a denominator. Okay. Then what you're going to do is you're going to reduce these fractions. So negative 14 over 4 can be reduced by 2 to give you negative 7 and 2. And then 10 over 4 can be reduced also by 2 to give you 5 over 2. Then what you're going to do is the denominator is going to have your x term. You're going to put that to the top, and that becomes your factor. So 2x and then minus 7 is one factor, and 2x plus 5 is your other factor. So you have to multiply this out. You would get the same thing you started with, the 4x squared minus 4x minus 35. We don't want to multiply it out. We actually want to solve it. So we're going to take each one of these factors again, set them equal to 0, and solve for x. So x will equal 7 over 2 and negative 5 over 2. Okay? All right, so now we've done two types of factorings. We've done the basic factoring, we've done the factor by grouping, we've even done the bottoms-up method. Okay. One word about the factoring. You can use the factor by grouping on any of these problems if you wanted to. It's just excessive. I wouldn't do it, but you could. The bottoms-up method, I suppose, would work as well. Yeah, it would. It just, again, kind of excessive. Okay. All right. On to 5 and 6. 5 and 6 are a specific type of quadratic equation, and these you're going to solve by using square roots. And the reason being is because if you look at the previous four problems, they have an x squared and an x. These problems don't have that single x term because although this x plus 4 in number 5 is by itself, it is being squared, outside the parentheses. Okay. So what we're going to do, in fact, then, is we're going to get that square root, or whatever is being squared, whatever term is being squared by itself first. So we're going to add 7 to get that number to the other side. So we're going to get x plus 4 squared is equal to 17. And now that term that's being squared is technically by itself. So to get rid of that squared part, we're going to do the opposite of squared, which is the square root. So the squared and the square root will cancel each other out. You'll be left with x plus 4 equals. Now, here is a problem that all students seem to have when we're doing these problems. Every year it's the same thing. I'm going to tell you you're going to do this wrong, and some of you are going to still do it anyway. All right, and what that is once you take the square root of both sides of an equation, the part that's being squared root on the right-hand side here should have a plus or minus. Okay, this accounts for the fact that there are two answers to a squared problem, or two possible answers to a squared problem. So you have to have a positive and a negative. All right, we finish out this problem by subtracting 4. So x will equal negative 4 plus or minus the square root of 17. Now this is as far as we want to take this. Technically, if the square root can be reduced, you could reduce it. We're not going to at this point in time. I don't think we're going to delve into that as much. If it is a perfect square, you do have to reduce it. If it's just something that can be reduced using a perfect square, then you don't. But you should have something that ends up like this. Number 6, the same idea, except this time it's not a parentheses that's being squared, it's just an x. So we're going to do the same idea. We're going to get whatever's being squared by itself first. So to do that, we subtract 7. So we got 2x squared is equal to 25 minus 7 is going to give you 17. 18, sorry. I could do math in my head. Next, the 2 part is not the part that's being squared, just the x's. So we want to get the x by itself because that's the only part that's being squared. So we divide both sides by 2. So now x squared is by itself. So the part that's being squared is by itself, just like we did on number 5. And 18 divided by 2 is 9. Now, to get rid of that squared, we can square root both sides. So the squared and the square root will go away, and you get x is equal to. This is a case where it is a perfect square. So the square root of 9 is 3. But again, you have to remember to put plus or minus because you did take the square root of both sides of an equation. That is solving using square roots. Okay. The last two are going to be solving using the quadratic formula. So if you don't remember the quadratic formula is off the top of your head right now, well, you should. But it is negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So the reason we use the quadratic formula for these two problems is because the other methods we've just gone over don't work. Okay, these 7 and 8 cannot be factored. They're not be solved. They cannot be solved using square roots. So the only thing we're left with is the quadratic formula. So, quick reminder. Quadratic equations in standard form are ax squared plus bx plus c. So the number in front of this is the a, negative 13 is the b, and the 2 is the c. The number in front of the x squared term, if you're not sure, is a 1. So we're going to put all these values into our equation, or into our formula. So negative b, if 13 is already negative, then it's going to switch the sign so it becomes positive. Plus or minus the square root. Now, make sure you always put the b squared term, whatever the b is, in parentheses before you square it. This causes a lot of issues, mainly because if you put negative 13 and square it into your calculator, it'll give you negative 169. If you put negative 13 in parentheses and then square it, it'll give you positive 169, and positive is the correct answer. So we're going to finish filling out the formula. 4 is part of the formula, A is 1, and C is positive 2. Okay, we're going to divide by 2 times 1, and now we start to simplify. So I would suggest doing the entire square root, whatever's underneath the square root, all at once. So we have negative 13 squared minus 4 times 1 times 2 gives you the square root of 161. 13 plus or minus 2. And that's all we need you to do. That's it, you're done. That's the answer. Say it again at number 8. So this is our A, B, and C terms. So you're going to have, if B is already negative, you're going to have positive 11 plus or minus the square root of negative 11 squared minus 4 times 5 times negative 4 divided by 2 times 5. Now again, I would highly recommend you do the part underneath the square root all at once. So you have 11 squared, actually negative 11 squared, sorry, minus 4 times 5 times negative 4 gives you 201. So we have positive 11 plus or minus the square root of 201, all divided by 10. We're going to keep it just like that. Okay, and that's it. That is solving quadratic equations with those 4 different methods. Right? You pick whatever method works the best for that particular equation, and then you solve it. All right, good luck with the practice.